Hello everyone, in this video we will understand and design and simulate this circular waveguide. And the previous video we have seen how to design and simulate a rectangular waveguide. So to design a circular waveguide, just click on the new template here. After clicking, you need to wait for a few seconds and select here the microwave. After selecting the microwave, you will see here the antenna, circuit component, radar, cross section. Just you need to select this antenna section, and you can see the highlighted portions. Antenna is selected, and just click on next. And here select the waveguide is pre-selected, so you need not to change anything. Just click on the next. After this, you have to select this time domain. Just click on the next. Here these are the dimensions for your parameter, so you need not to change here again. Just click on the next, and here you need to decide the operating range for the circular waveguide. Just let's say the minimum frequency is 1 GHz and the max is operating frequency is 9 GHz, and you have to select here the what parameters you want to observe after designing and simulation your circular waveguide. So select the electric field, magnetic field, far field, power flow, power loss within a circular waveguide, right? All these parameters you can see after the simulation of circular waveguide. Okay, here you can rename this project. Let's say we are designing a circular waveguide, so you need to write here circular waveguide designing, and just click on the finish button. Okay, here we have some error. This application has interpreted runtime to determine it in an unusual way. Please contact the support team. Okay, this is the runtime error. Okay, that was the software problem. We had just restarted the software and we got this here, this designing part window. So to design a circular waveguide, you need to click on the modeling first. And previously for the designing of rectangular waveguide, we selected this brick box. Now to design a circular waveguide, we need to select a cylinder. Just click on this here cylinder part and press escape in your keyboard. Here you can see, double click on the center of working space or click on the escape button. Okay, after pressing the escape, you can see the dialog box to decide a dimension of your cylinder. Let's say you want outer radius of 20 and you want to make a hollow, so let's say inner radius is 17, X center is 10, Y center is 20, Z min 20, Z max 20, and here you want to select a material. Let's say we want to have aluminum waveguide. Okay, after selecting the aluminum, just click on the OK button. Here we have a cylinder, hollow cylinder. Here you can see, right? This is a hollow cylinder. This will act like a waveguide. Now to decide the port of this waveguide, we need to click on its face first. Okay, after click on the simulation and decide the port, you need to select the face of this waveguide. Now select this highlighted part. Sorry. Okay, just double click over here. Okay, this is selected now, and click on the waveguide port. and you need not to change here anything. Just click OK. It will decided a port 1. You can see here this is decided port 1. Now rotate it to the back side and again click on the pick face and pick a second face here this side. Just double click over here. This dotted line is showing that this is selected. Now click on the waveguide port again. Here you can see, after clicking over it, you can see a new dialog box. Just click on the OK button. You can see this is automatically assigned the port number 2. Just click OK. After this, you can see this port number 2 has been decided. To simulate this waveguide, you need to click on the setup solver. Here you can see this is the setup solver. Just click on the setup solver and you can see here another new window. You need not to change anything here. Just click on the start button. After clicking the start button, this model will save all the files of designing and it will start the simulation part. Here in this window you will see the simulation processing. Here you can see there are few warnings. After the warning, the processing has been started. It may takes more than 10 minutes, so we have to wait until this is complete, and we will see the results for this circular waveguide. Here you can see there are no 1D 2D results. There is no results here till now. After the completion of this simulation, you will see all the results in the 1D and 2D far field, right? So there is no results of 1D and 2D, so we need to wait for the results to appear here. In the 1D results section, you can see here the results are shown here some, but it is not complete yet. Processing is undergoing, so we need to wait until it is complete in this section. Okay, all done here. You can see the processing is complete. There is no processing right now. There are only 5 warnings. Just ignore the warnings. Now you can see here the result section, the 1D results and 2D results are completely shown here. Let's see the port signals. you can see the signals on the ports I1, I2, right? And here you can see the S parameter, sketching parameters graph, S11, S21, S12, S22, right? These are the graph for the S parameters, and you can see the power graph, right? And you can see the energy graph also, and VSWR graph, voltage standing wave ratio. And in the 2D and 3D results you can also see the ports mode. Let's say port 1, we need to check it, electric field. Okay, this is the direction of electric field in the circular waveguide at port 1, and magnetic field would be in this direction at the port 1. And let's check on the port 2. At port 2 you can see, at port 2, just rotate, this is the port 2 here. Magnetic electric field direction is what, and the magnetic field direction is to the rightward. Okay, these are the port signals and the direction of magnetic and electric field. Now check the electric field at frequency 3 at port 1. Let's wait. Okay, this is the electric field. Within this circular waveguide at frequency f equals to 3 GHz. Similarly you can check the magnetic field. Okay, you can see the magnetic field just rotated. Okay, this is the magnetic field shown by the dotted lines, arrow lines. We are unable to see complete. Let's animate this so that we can see what is the direction of magnetic field. Right, this is the direction of magnetic field to the rightward, right? You can see through the animation. Okay, here you can see the surface current also. Okay, this is the surface current within this circular waveguide. You can see here at the different frequency. You can check. I'm just checking at frequency 3 at port 1. You can check at all frequencies and all ports. Okay, now you can also see the power flow at frequency 3 at port 1. Just wait for the processing. Okay, this is the power flow within this circular waveguide. And far field you can check. Okay, I hope all the things are clear to you right now. You learned how to design a circular waveguide and how to simulate and how you can check the results in this circular waveguide. To understand all these parameters for the circular waveguide, you need to go through the theory part of for this circular waveguide, because without knowing the theory or concept for the circular waveguide, you were unable to understand how the electric field, magnetic field waves propagate within this circular waveguide, right? And what are the power flow, what is the scattering parameters, how the graphs were plotted. This software just simulate, design, simulate and give you the direct results. To understand all these results, you need to have the understanding of all the theory part for this waveguide designs, right? Okay, thank you for watching this video. I hope you like this designing part of circular waveguide. To learn more about this waveguide designing and other things, just click on the subscribe button. If you have any question regarding this designing and results, you can write in the comment box, and don't forget to hit like button. Okay, thank you very much so much.